Today we will talk about fresh air handling unit capacity calculation. Okay, how to calculate the tonnage for the FAHU coils. Okay, last week we have seen how to calculate the airflow rate for the fresh air and for the exhaust based on the ASRAE 62.1. Okay, based on the different classification, different rooms. Okay, different occupancy category. We saw that how to calculate the airflow rate. Okay, now today we will talk about capacity calculation, like basically what will be the capacity for the cooling coil. Okay, so to understand that one, this is the basic equation. Okay, this is the air side equation and derivations. So how to calculate sensible load, which is nothing but 1.08 multiplied by CFM multiplied by delta T. Okay, this is to calculate the sensible load, okay, for the coil. Then latent load. To calculate latent load, this is the equation 0.68 multiplied by CFM multiplied by delta W. Okay, so this is the humidity ratio in difference. Okay, in grains. Okay, and when you calculate in pounds, this is the value. This is the equation. Latent load is nothing but 48.
Pardon, for the sensible ரெண்டுமே ஒரே ஃபார்முலா இருக்கு with 1.08 and 1.1. அதுக்கு என்ன டிஃபரன்ஸ்?
No, actually there is both are same only. There is no difference. Actually, when you say for example 1.08, okay, this is a 2 digit. When you make it 1 digit, this is 1.1. That is only the difference.
Making it on top.
Okay. Yeah, only that is the difference. There is no other equation. But if you want to know how this calculation is arrived, then I can send you one video. Okay, basically you know that Q equal to mCp delta T, right?
Yes.
So there is a specific heat. Okay, then there is a density. So when you multiply by all this value in minute, okay, say for example Q equal to mCp delta T. Okay, so that value will be in kilogram, that value will be in hour, or that value will be in density kg per meter cube. Okay, that value will be in specific heat. So when you multiply, when you compress all values, okay, density, specific heat, and convert from hour to minute, okay, so this value will come. Okay, so that is the derivation, but the basic formula is Q equal to mCp delta T. That is the basic equation for the heat transfer.
Fine.
Okay, so for the sensible load, this is the value 1.08 or 1.1 multiplied by CFM multiplied by delta T, temperature difference. Okay, like this is the sensible cooling, right? Sensible is nothing but change in temperature. When you go to the psychrometric chart, you will understand the change in temperature is nothing but sensible heat.
Yeah.
Okay, then the latent heat is nothing but 0.68 multiplied by CFM multiplied by humidity ratio. This is a change in humidity ratio, not the temperature difference. Change in humidity ratio. When you go to the psychrometric chart, you can able to apply that humidity ratio. Okay, so this is the humidity ratio where you can see the grains and you can see the pound. The LB is nothing but pound. Okay, so say for example, I think 7,800. If I multiply by this value, okay, 4840 divided by 0.68. Okay, so 7,120 something pounds is nothing but 7,120 grains is nothing but 1 pound.
Okay.
Okay, so that is why this equation will be latent heat is nothing but 4840 multiplied by CFM multiplied by delta W in pounds. Okay, so you can see the humidity ratio in pounds, that value. Okay, then to calculate the total value is nothing but 4.5 multiplied by CFM multiplied by delta H, enthalpy difference. So this is the basic equation for you to understand when you do the capacity calculation, whenever you do work with air conditioning equations.
So total values either you can do individually or the sum
you can do both. Yes, you will get the both value.
And CFM will be taking from the calculations for the exhaust and supply.
Yes. Okay, clear, right?
Yeah,
clear.
Okay, now let me go to one of the picture, okay, to understand what is there in the FAHU. Okay, so you can see here, say for example this is the FAHU. I think most of the people have seen in the site, right? Inside there is a coil. Okay, then you can see the wheel. This is called enthalpy wheel. Then this is called sensible wheel. Okay, to change in temperature, right? And you can see the exhaust blower, and you can see the fresh air blower. Okay, so basically you can see that this is called a fresh air handling unit. Okay, where you can save the energy, right? Okay, say for example I will go to one of the option. Okay, assume that there is without any enthalpy wheel or sensible wheel. Okay, so if you go to one of the equations where you can see one of the FAHUs where you're taking air from outside and you're going to supply into the space. Okay, so say for example, this is your fresh air handling unit, but it is one way. Okay, it is nothing but one way. Okay, say for example, in some of the chemical rooms, okay, this depends upon the application. Okay, say for example, in of the chemical rooms or in hospital or whenever you go to the area where you have a contaminated, okay, where you cannot do the recycle. So that particular area you will do this type of fresh air handling unit. Okay, so the fresh air handling unit will be used for the cooling purpose and also used for the ventilation purpose. Clear, right? So here how to calculate the capacity for the cooling coil. You can see the outdoor air. Outdoor air will be, say for example, if you are using it for ventilation purpose, you can use it for 34, 32 as per SAFAT regulation. But if you are using it for both for cooling and ventilation purpose, then you can take the peak load, okay, which is 46.1 or 20.4. Okay, 20.4 is nothing but the humidity ratio. Okay, so if you go to the SAFAT regulations, if you go to SAFAT regulations, they have given basically 34, 32, right? 34, 32 is the temperature. Okay, but if you go to psychrometric chart, okay, if you go to psychrometric chart, you can see there are different values, right? You have a tribal temperature, relative humidity, dew point temperature, absolute humidity, then after that enthalpy, wet bulb temperature, specific volume. Okay, so you should know the two values to arrive the other values. Okay, say for example, tribal temperature is 34 degree. Okay, and wet bulb temperature will be 32 degree. Okay, you can able to calculate all other values in SI unit or in IP units, right? Okay, so this is one of the procedure to find out all other parameters. Okay, now I want to calculate the leaving temperature. So what is my leaving temperature is required based on my supply temperature. Okay, supply temperature will be for the standard air conditioning industry. I will tell you that 11 degree and dew point temperature will be, the wet bulb temperature will be, say for example 10.4. Okay, I will tell you how this value came, that I will explain you later. Okay, so this is the calculation. You will get both conditions, right? On coil and off coil conditions. Okay, so in this table you can able to calculate delta H, right? The delta H difference on coil and off coil, you can calculate delta H, or you can calculate delta humidity ratio. This is the humidity ratio. So you can see that on coil and off coil, what is the difference? You can get this value, right? And also you can able to get the dry bulb temperature difference, delta T. Okay, so if you go to this equation, you can able to calculate delta T, you can able to calculate delta H, you can able to calculate delta W by using this psychrometric chart. Clear, right? Okay.
Yeah.
Okay.
Okay, basically if you go to this particular guideline, okay, if you go to this picture, you can able to see this is a one-way FAHU. So one-way FAHU, you have a cooling coil. Okay, how to calculate the cooling coil? The capacity of the cooling coil will be based on tonnage or based on kilowatt. Okay, so what are the loads? You have a sensible load, you have a latent load. Okay, how to calculate sensible load? There is the equation. How to calculate latent load? There is the equation. Okay, how to calculate total load? There is the equation. Clear, right? So to calculate sensible load, you can go to that equation. To find out sensible load, you want to know the delta T. Okay, CFM you know already, you calculated. So you want to know the delta T. So if you know this two value, you can able to calculate what is the total sensible load.
Yes, CFM, how do we calculate?
That is based on the ASHRAE standard, 62.1. That is what we have seen last week. Based on the ASHRAE.
The flow rate, yes.
Yeah, based on the flow rate, right?
Yeah.
Okay. Now,
so delta T would be difference between?
Delta T between difference between outside temperature and the supply temperature.
Other than what is as per design, what is required as a supply temperature? Yeah.
Yeah. What is the supply temperature? Yeah, we can take it. So you will come to
grill temperature, right?
What is that?
Supply temperature is a grill temperature.
Grill temperature. Yes.
Yeah.
Grill temperature, or you can say normally grill temperature. grill temperature will be, if it is far away, then you will have a difference of +1. But actually off coil means it is after the coil, what is the temperature?
Okay.
Yeah, so off coil is the supply temperature, yeah?
Yeah, it will be the supply temperature.
Okay. Also, no, yeah, that's it.
Yeah. Okay. So now you know the delta T. Okay. If you know this two conditions, condition 1 and condition 2, then you can go to the psychometric chart. You can able to calculate the
And,
condition 1, condition
this,
2.
sorry,
Yeah.
this delta, I mean, the supply temperature, we
Okay.
can set it, no, as per the design. Let's say in that building, we would like to keep it at 19, the supply temperature at 19 or 16. So based on that, we can make the calculation.
See, I will tell you one more thing. Okay, how to calculate the supply temperature. Basically, okay. If I go to psychometric chart, okay. See, this is your psychometric chart, right? Your psychometric calculator. Okay. Say for example, I want to what is the as per Safath regulation for the human comfort? What is the temperature? 24 and 50% RH, right?
Yeah.
Okay. Now, if you calculate, you will get dew point temperature. Okay.
Okay, this dew point temperature is the off coil temperature, right?
Yeah, diff coil temperature is nothing but off coil temperature. Actually speaking, okay. But still, you have to study a lot of things. There is a apparatus dew point temperature. There is a bypass factor. Okay. Okay. Now I will just draw here. Okay, one small picture. Say for example, this is psychometric chart. Assume that this is psychometric chart. Okay. Okay. Now say for example, what we have seen 24. 50% RH, you will get this particular point, right? If you go to the psychometric chart. Okay. If you go to straight, if you go and hit this value, if you go to intersect here, you will get dew point temperature, correct? So assume that that is a supply temperature when you have only sensible load.
Okay.
Okay, in the space, assume that they had data center or go to wherever you have a server rooms, there you have only sensible load. Okay, so that means there is no latent. So your cooling will be directly straight towards the psychometric chart. It will go and intersect here. So that will be the supply temperature. But when you go to the comfort cooling, you have a both latent and sensible load, right? Okay. Now you know that value called the sensible heat factor is nothing but sensible load divided by total load.
Yes.
Okay. So if you go to psychometric chart, you might have seen maybe you can also able to see in future there will be semicircle in the psychometric chart. Have you seen somewhere? Okay, so this semicircle, this is to find out what is the sensible heat ratio. Okay, so say for example, sensible heat ratio is nothing but sensible load divided by total load. Okay, so you will get some percentage. Say for example, 0.6 or 0.7 or 0.8. Okay, so what you will do from this center, you will make a line. Assume that this is the 0.1. Well, this is 1. 1 means a straight value. If I have a sensible load of 1 means what? Straight.
100% is the total load.
Yeah. If you give me some time, I can able to search that psychometric chart. I think I have shared in the group. I'm just searching the psychometric chart. Okay, just to get idea only. Okay, you can see this psychometric chart, right? You can see. Okay, so if you go to psychometric chart, okay, you can see. Okay, so if you go to psychometric chart, okay, you can see. Okay, just for just to get idea only. Okay, you can see. Okay, just for just to get idea only. Okay, you can see. Okay, so if you go to psychometric chart, okay, you can see this psychometric chart, right? You can see this picture you can see, right?
Yes.
Okay, you can see this is a semicircle, right? So in this semicircle, you can see like 1, 0.9, 0.8, 0.7, 0.8 will be there. Okay, this is called sensible heat factor. Okay, say for example, if I have a sensible load only in my space, so I can use this particular chart, right? This particular calculator. If I go to 24, if I go to 50% RH, then I will get dew point temperature 12.98, which is directly the sensible load. Okay, based on the sensible load. So that means if I go to this picture, if I say sensible heat factor, my sensible load and total load will be the same. So I will get 1. So if I get 1 means then I will draw here 24, 50%, then I will draw a line. I will hit here, that will be the supply temperature. Clear, right?
Yeah.
Okay. When I say for example 0.9 or 0.8, then the line will be inclined, right? So that inclined line will come and hit here somewhere. It will intersect here.
Okay.
Okay. So that will be the, basically that will be the off-coil temperature.
Okay.
Clear, right? But off-coil temperature cannot be same because of the bypass factor. You know what is bypass factor? There will be some air will be escaped between the coil. So that means it will come somewhere here. Okay. So when you go down, you will get actual supply temperature. So that is that this particular explanation is given in that cooling and dehumidification lecture. If you go to that video which I shared, cooling and dehumidification, you can able to see this explanation.
Fine.
Okay, so I think Fahad Selva, just to go through that video, you will get basic psychometric understanding. Okay, clear, right? Okay, so now this is the supply temperature. So if you go to this particular guideline, you can able to calculate what is the supply temperature, right? Okay, so if you know the supply temperature and if you know what is outside temperature, you can able to calculate delta T, you can able to calculate delta W, you can able to calculate delta H. So that by using that equation, you can calculate sensible load, you can calculate latent load, you can calculate total load, right? Okay, so if you know this 3 value, then you can able to make a schedule. So what is the FAHU schedule consist of? If you go to this particular sheet, you can able to see here, FAHU schedule consists of fresh air flow rate, exhaust air flow rate, and assume that we are not going with heat wheel as of now. Okay, we are going with the cooling coil. So you know what is the cooling coil, air on coil temperature, and what is the air off coil temperature. You can able to calculate, right? Based on the air on coil temperature, air off coil temperature, which is coming from the psychrometric chart. You know what is air on coil temperature, what is air off coil temperature. Okay, so based on that, you can able to prepare the schedule here. Then what is the capacity, total capacity, nothing but sensible load plus total load. And sensible load, you can able to calculate, right?
Yes.
So by this, you can able to prepare your equipment schedule. Okay, for the FAHU. It's clear?
Okay.
Okay. Now we have another conditions. Say for example, I'm not going with the one. I want to save some energy. Okay. Say for example, I'm spending 98.6 TR. Okay, but I want to save some energy if I'm using it for normal application. Okay, normal application, my contamination will be lesser, right? So also say for example, I can able to utilize whatever the returner from the space. Okay, for the energy saving. Okay, so if you go to this particular picture, you can able to see this type of FAHU, right? So you can able to take the return from here. So this return, it will transfer the energy only, not the airflow rate. Airflow rate will not mix, only transfer the energy. Okay, then after that it will.
This one has heat recovery also, no?
Yeah, this one has heat recovery wheel. Okay, so when the returner temperature comes from outside, it will transfer the energy. Okay, so I can show you one of the picture for you to understand. So you can see this picture, right? So this is the sensible heat wheel or total heat wheel. Okay, so you have a motor here, then there is a heat wheel, then the heat wheel connected with the belt. Okay, the heat wheel will keep on rotating so that it can transfer the energy from one area to another area. Whenever the fresh air or outside air, when it pass through this heat wheel, what will happen? Whatever the temperature, whatever the load on the air will be transferred from one space to another space. Say for example, if I'm going to supply cold cold temperature, 24 degrees Celsius. What will happen? So this temperature is the cold temperature. Okay, whatever coming from outside temperature is 35. So whatever the 35, it will absorb that this particular area will be heated up, right?
Yeah.
Okay, and this heat will transfer here. So what will happen? This outside air temperature, the return temperature will increase the temperature. Okay, why it is increasing? Because it is absorbing the energy from here, right?
Yes.
Okay, whatever the cooling, it will transfer here and it will try to cool here. So 35 degree will become 26.4 and 24 will become 32.6, because this is exhaust air which is a stale air, right, which is going outside, which is not usable. So we can increase the temperature, there is no problem. But whatever required to space temperature, we are going to reduce the temperature. Why you are reducing the temperature? So that you can able to reduce the cooling coil load. Okay,
one moment.
Yeah.
Can you just go to the
picture?
Yeah. Now we have the outdoor air temperature of 35.
Okay.
And the supply becomes 26.4.
Yeah.
Whereas the return air becomes 24. It should be opposite, right?
No,
that should be lesser than the return, correct?
No. It doesn't mean that. No, it's not like that. See, this is, there is no mixing here. There is no mixing here.
Okay.
This is return temperature is nothing but which is coming from out, which is coming from the space basically.
Okay.
You mean to say that this temperature should be uniform to this temperature?
No, usually the supply temperature should be less than the return temperature, correct?
Yeah, that is okay. That is okay. I understand what you are saying. Now this is just to reduce the capacity or the cooling load only. Okay. After that, what will happen? This supply air will pass through the coil, right, for the dehumidification purpose. Then that time it will go to, say for example, 11 degree, 12 degree.
Okay, fine.
Okay, so that 11 degree, 12 degree only it will be supplied to the space after the sensible wheel. Okay, so this is just to explain that what is the condition. Say for example, if I increase the heat wheel width, then the condition will change. If I reduce the diameter or increase the diameter, this will change. If you go to, there is one famous manufacturer called DRI. Okay, so if you go to that website, okay, maybe I can share you some of the videos for you to understand what is the heat wheel and all. Okay, there are different type of diameter available, there are different type of thickness available. So I cannot calculate from my side, because this is purely what type of heat transfer. It's a conduction heat, right? It is same like wall, right? So this calculation will be done by the manufacturer. Okay, depends upon the diameter of the wheel, depends upon the width of the wheel. They can able to do the calculations, right? Okay, so now what we are doing, we are just going to get what is the off wheel temperature. What is off wheel temperature based on the manufacturer? What is the result we will get? So based on that result, only we will calculate our coil capacity. We are just calculating only the coil capacity, cooling coil capacity. Okay. Now say for example, I have shown one picture here. This is a picture, right? So in this picture, you can see the outside temperature is 34, 32. Okay, which is coming from outside to this wheel. First wheel called enthalpy wheel. Okay. Okay. Now from here, from the return from the space, assume that 25.18.7 or whatever the temperature which is coming from the space. Okay. So what will happen? This is just exchanging the heat. So this heat will be exchanged here. Okay. This whatever the cooling, this cooling will be exchanged here. So whatever the cooling temperature will be transferred here, the hot temperature will be transferred here. Okay, so when you transfer the hot temperature, this temperature will be increased. So this is what your condition, this is what my required condition. Okay, I cannot supply 12.8, 12.2 into my space, right, because this is a fresh air handling unit. Fresh air handling unit supply temperature should be close to the returner temperature, right? Okay, so I cannot supply 12.8 by 12.2 into my space, because the humidity will increase, then moisture will increase, then the room will be overcooled, because I have already AC machine for the cooling purpose, right? This is what is the fresh air ventilation purpose. So ventilation purpose, I should just replace the existing air. Okay, I am going to take out some of the exhaust air and then I have to replace that fresh air. So when I replace my fresh air, I should match with the same as return temperature, right?
Yeah.
Okay, so why this return temperature is very lesser? Say for example, you can ask me one question that why 25 here and why it is 20.8 here. Say for example 24, this particular FAHU will be used for multiple floor, right? Say for example, maybe this particular FAHU will be installed in middle of the 24th floor and it will be supplied to 50th floor. Okay, so it is going from far away. Okay, so there will be change in temperature plus or minus 1 or 2 degrees Celsius, right? So say for example, my room temperature is 24 degrees Celsius and 50% RS. But when it reaches to the coil, to my wheel, there is increase in temperature because of the long travel. So that is why here there is increase, and here we have to cool lesser than the supply temperature, so that when it reaches to the space, I will get same temperature. You clear, right?
Yeah.
Okay, so this is the condition. So I know this condition, I know this condition. So based on this condition, I know this condition. So there are some conditions I know. Say for example, this condition I know from outside temperature. Then I know this supply temperature. I know this temperature, right? So when you apply inside in the calculation in the software, you can able to calculate this temperature, and this temperature. If you apply on the software, you can able to get this temperature here. This is just by using same UA delta T. Okay, same as conduction heat transfer equations. But basically, we are because this is from the manufacturer. What is the diameter of the wheel? What is the width of the wheel? Okay, to give best efficiency, they will do the selections. So based on that selection, you can able to get the result. Okay, I will be sharing one website for the DRI website where you can able to enter the on coil temperature and off coil temperature, or the heat wheel temperature. You can able to get the other values. Okay, so basically you are going to enter this value to find out what is the off wheel temperature, which is nothing but on coil temperature, right? Okay, so you can able to calculate what is off coil temperature. So if you know these two conditions, then you can easily calculate what is the sensible load, what is the total load, and what is the latent load, right? Basically, you are going to find out this equation from that software.
Okay.
Based on that outside condition, and based on that your supply temperature, and based on that inside condition. Okay. Okay. I will try to get that website now. We will see how to get one of the sample. We will work it out. Okay. So you understand how to calculate the capacity.
Yeah.
Clear, right? What is the method? Okay, but you have to involve manufacturer, because see, as a consultant, we know everyone know that whenever we are doing, we cannot do only depends on the theoretical calculation. We have to live with the manufacturer to get actual calculation. That you are aware of that, right?
Yeah.
Okay. So this is one of the type of the FAHU. Then if you go further, right? This is what we have seen now. Okay, with one heat wheel. Okay. So what is the temperature difference? You can able to calculate the cooling coil, right? You have any doubt by seeing this picture? How to calculate sensible load, latent load? You can see the condition 1, condition 2, condition 3.
You can make one sample calculation if possible.
Okay, I will do from here as a one. This is a simple calculation. I will do it here. Okay, let me write my equations here. Delta T, right? So latent load is nothing but 0.68 delta W, right? Okay. Now, if I go to psychrometric chart, if I go to psychrometric chart, I can able to enter the values here based on the conditions here, right? So this is one of the conditions. I will take this condition 35 34, 32 as per SAFAT regulations. So this is 34 and wet bulb temperature will be 32, right? So I can calculate all other conditions. Then what is the off coil condition? If I go to this picture, 12.78, okay.
This 12.78, how we received is from the
From the psychrometric chart,
not
from the psychrometric chart. That's what I explained you, how to calculate everything, right?
Okay.
Okay. Now assume that my dew point, my wet bulb temperature will be close to the uh, uh, my dry bulb temperature, okay, because it is passing through the coil, okay. So it will be actually, it will be same as dry bulb temperature, but it will not be same because of the bypass factor. So I will assume that there is some bypass factor. So I will go 12.1, assume like that, right? You got it, how I got this value. Okay, then I will, yeah.
Only meeting recording the record, please.
Yeah, it's recording, yes.
Okay, fine.
Okay, so this is the value, you can able to get this value, right? So now we know what is a delta T, what is delta W, and what is delta H. Okay, so if I go to this equation here, so I will just convert from SI to IP. Because why I am converting from SI to IP? Because my equations all are in IP. Okay, if I go to these equations here, if I go to this equation, it is like a CFM. It is an IP and delta T, which is in Fahrenheit, right? Okay. Now if I go to this one, 1.08. Okay. And what is the CFM? If I go here, CFM is nothing but 17,000 meter cube per hour. Okay. So to convert 17,000 meter cube per hour, divide by 1.7. So this is my CFM, right? Clear, right?
Okay.
To convert,
Yeah.
convert from meter cube per hour to CFM, divide by 1.7.
Okay.
So what is the temperature difference? I can go to the psychrometric chart. I can able to calculate here 93.2 minus 55, right? So this is my delta T. So if I calculate my sensible load, multiply by 1000. So this is my, what is the value? BTU per hour, right? This sensible load, this equation is in BTU per hour. Okay, if I want to calculate my capacity, which is in tonnage.
Kilowatts.
Tonnage. Here it is tonnage. Okay, so I will go to this equation. So to get my tonnage, divide by 12,000, right? So which is 34.65. You can see this value here, 36, right? 36 ton here. Okay, so that is what we calculated here. So we calculated very close value, because I have to get the exact value from the chart, but this is the concept. You understand the concept, right? Sensible load. Now I am going to calculate latent load, 0.68. Okay, 10,000 and delta W. So delta W, if I go to the chart here, I can able to calculate what is the delta W, right? 222 minus 61. So now I'm going to multiply by this value. So if I divide by 12,000, I will get 91.2, right? So this is very close to this value. Sorry, 1 minute. Let me calculate. There is some mistakes happen. This one in grains per pound, right?
Can you go back to this psychometric that calculation? I think you put SI readings.
Wait 1 minute. No, it's IP only, right? It is IP only. This is the difference.
No, okay.
Okay. Anyway, we will see now. We will see now. What is the total load? The total load is nothing but 4.5 CFM delta H. Okay. Okay. Delta H is somewhere here. 57.3 minus 22.7. Okay, maybe because of that some small change in temperature, this is the difference. Okay, now if I calculate this two, am I getting 125? So actually supposed to be very equal temperature, but this is the way to calculate your sensible load, latent load, and total load. Right? You understand the concept, right? Because of some change in temperature, I am getting different value. Okay, but this is the concept. Calculate sensible load. Okay, 1.08 multiplied by CFM multiplied by delta T. Okay, 1.08, and this is the CFM. Delta T will be the delta T temperature difference on coil and off coil temperature. And by this equation, you can able to calculate the total value, which is in BTU per hour, and divide by 12,000, you will get tonnage. Right?
Yeah.
Tonnage of refrigeration. Then for the latent load, the same equation, 0.68 multiplied by CFM multiplied by delta W. Okay. Then for total load, same equation, 4.5 multiplied by CFM multiplied by delta H. So you will get total tonnage. So when you add this together, it should be the same. Okay, because we are using different equations. Okay, supposed to be 129, very close to that value, but if you go to use calculator, it will give you the actual value. Okay, but this is the equation to get total load. Okay. Actually speaking, this is supposed to give the total correct exact value. But let me see what is the mistakes. Why we are not getting actual value here? Let me check 1 minute. 45. Okay. So here it is 35. Let me go and check the other value as well. It is 35, 32. Okay, here it is 25.1 gram per kilogram, right? But based on our condition, it is actually 0.0312 kilogram per kg, which is nothing but multiply by 1000. You will get 3, 30, 31, right? You understand, right? This is the kg per kilogram. So that is the difference. That is why we are getting different value. Okay, but if I make it, assume that if I make it 25.1 close to that value, maybe I will get that temperature. Say for example 35. Okay. Yeah, you can see 99.6, 99.3 this value, right? So now I will go to this one and I will see what is the temperature here. See, it is 175, right? Not 22222. It is 175 based on that condition, delta W. So if I go 175, so now it is matching, right? So if I go to the delta H, which is 50.4. Now you can see which is 99.29. So 99 point, exact the same value, right? Total load.
Yes.
You can able to see the total load 34.65 plus 64.6, which is nothing but 99.25, exactly the same value. So this is the sample calculation. Maybe I can send you this this Excel sheet for your reference.
Yes, please.
Okay. Okay. Now you got idea how to calculate the total load, sensible load, and latent load, right? Now I'm going to the picture for another scenario. Okay, so this is one of the scenario, you understand. Now this is another scenario, you got idea, and then this is another scenario where you are using pre-cool and preheat pipe. Okay, pre-cool and preheat pipe is nothing but you can see the picture. Okay, you can see this picture, right? This is the cooling coil and this is the heat pipe and this is the heat pipe. This is called heat pipe, pre-cooled and preheat. Okay, so this also will do the same purpose of the sensible wheel. Okay, but this has less efficiency. But this is also one of the type. What it does? Say for example, you have a refrigerant here, right? This is a refrigerant, and you can see that there is a pipe is inclined pipe. Okay, what will happen? The hot temperature will go on the top. Okay, and the cold temperature will be on the bottom. Clear, right? So the cold temperature will be here. So when the hot air comes from outside, it will cool the air here. After passing through the coil, what we have to do? We have to increase the temperature. So the hot temperature is here. So it will increase the temperature. You got idea?
Yeah.
So this is one of the application, one of the types, okay, of the fresh air handling unit. Okay. So now whenever we do the calculation, when as a consultant, when we do the calculation, we will do one with the with the heat wheel and one wheel with the heat pipe, and we will see which is the best efficiency. Okay, in terms of energy consumption. Then that's the way we will choose which type it is. Say for example, this is one of my project. Okay, like where we worked in downtown. Okay, so you can see here they have selected total recovery wheel and sensible wheel. Double wheel they have selected. Okay, but if in case if you see that if you go with the preheat pipe, If that efficiency is which is better, then you may go with the preheat pipe. Okay, this condition will depends upon what you are getting from the space and what is the airflow rate. So this depends upon that condition will change. Clear, right? Okay, we have a different type of FAHUs. Okay, one is direct throw. Okay, and one is with the heat wheel before the coil, and one with the after the coil, after the heat recovery wheel. We have a pre-cool and preheat pipe, or we can go with the double wheel, heat recovery wheel and sensible wheel. Okay, and we have to see which is the best efficiency, where you are getting
Usually,
more. Yeah.
Usually,
Yeah.
which one is the most efficient one, and how do you calculate the efficiency here?
That you can see as a
Because it will
sample
be
here. No, that
actual
you can see.
situation, no?
Yeah, you can see as a sample, one of the sample for the same condition. Okay, in this one they have did one calculation, right? You can see in this picture. So what they did with the one with the cooling coil only. What is the temperature they got? What is the tonnage they got? 99.3. If they are going with the enthalpy wheel, you can see the how much saving. If they go with the enthalpy wheel with the wrap up around heat pipe, you can see how much saving. If they go with sensible wheel, how much saving, right? So if you go with the only cooling coil, you have to buy AHU of 99 TR. But if you go with the double wheel, the heat wheel, you can able to save energy of approximate 60 tonnage, right? So this is what a comparison sheet.
Yeah.
Okay, so that is why normally whenever you see most of the FAHU, they will be choosing with the double wheel. Okay, so double wheel is most efficiency in this case. But somewhere you cannot use double wheel. Somewhere, say for example, I have one FAHU is there, right? I have one FAHU, but I cannot use double wheel. Where you will use double wheel when you get air from the return temperature from the space, right? But I don't have enough airflow from the spacing. So what I will do, I will not go with the double wheel. I will go with the only normal FAHU. Okay, but what I can do, I can go with the cooling coil. I can go with the horseshoe heat pipe, right? To save the energy, horseshoe heat pipe will work from the on coil and off coil. What will happen? Say for example, outside temperature is very hot, right? So this hot will transfer here. Okay, after the cooling coil, it will be very cold. So this cold will be transferred here. You are getting right what I am saying?
Yeah.
So by means of this, it will save the energy. So there are different types available to save the energy. Okay, one if you cannot go with the double wheel, or if you cannot go with the heat pipe, then that application is different. You have to go with the one throw. Okay, I want to save some energy. You can go with the double heat wheel, but double heat wheel will be very costlier. So the client cannot go with that budget. Then they will go with the preheat pipe, but efficiency is lesser. So either you have to balance it. Okay, whether internal initial cost you have to balance or operation cost you have to balance. In that way, they will choose which is the best fresh air handling unit. But the capacity calculation as a to describe how to calculate the FAHU airflow rate and how to calculate the capacity and what is the method, that we have seen everything. Okay, but based on the energy consumption, you will select which type is the better. It's clear, fresh air handling unit.
Yes. And the efficiency, then we need to actual situation at
you will see the comparison. See, whenever you are doing project, you will ask from the manufacturer to give different options. One, you will ask them to give it the heat pipe. You will ask them to give it the double heat wheel. Then you will see which is the best one, right? Say for example, okay, now if you go with the heat pipe, it is 32.5, right? And if you go with the sensible double heat wheel, 28.4. So how much energy you are saving? 4 tonnage, right? 4 TR. So you will calculate for say for example 10 years, right? What is the life of the FAHU? Say for example 10 years. Okay, so you will calculate for 10 years what will be the savings in your energy consumption. Okay, and then you will compare with the double heat wheel material cost, because maybe you can say 30%, 40% will be the difference between these two options, right? So 30%, assume that your say for example 30,000. Okay, you will see that 30,000 price is really you are saving or not. Okay, say for example you are saving only 20,000, but you are going to buy 30,000. So why it is required? No, maybe you can go with the wrap up heat pipe only, right?
Understood.
Okay, so that is the way they select. That is in terms of initial cost and operation cost. Okay, but to do with the calculation part, this is what we have seen. Okay, so whenever you are doing with the wrap up around heat pipe, sensible wheel, you have to lie on manufacturer. Okay, they will give the selection, best selection, which can save more cooling. Okay, clear, right? Does anyone have doubt?
Yeah.
Yes, yes.